All right, so we are now going to kind of jump ship from our, well, we're still going to use our identities, but now I want to show you how you're going to use them to solve trigonometric equations. And I'll be honest with you guys, we're going to kind of just get into the introductory of this. We're not going to get too deep and crazy with the situation that we are in at this point. But with that being said, let's just take a look at your sine curve. And if we're looking on domain of 0 to 360 degrees, and we had to solve it for when does sine of theta equal 1/2? And I would hope that we could be able to use this, especially like use your unit circle at this point to be able to answer these questions. But we know our maximum right here is at 1. And so here's where 1/2 is. And we see that it crosses over at 2 points, even if you were to use your unit circle. And so where those values are is at 30 degrees and also 150 degrees. So solving those and seeing that there are two solutions to each other. Now, what I want you to think of is that with your unit circle, you have that you can see what the two values are. But what if you didn't have your unit circle and you're trying to solve this out? Okay, so we know that using your calculator to find an angle, we can take the inverse sine of 1/2. And if we're in degree mode, it's going to shoot out 30 degrees to us. Well, how do we get that 150 degrees on the other side there if you didn't have like your unit circle? Well, knowing that our curve right here and what it looks like, this first part right here to 180 degrees, there's some symmetry going on here. And so if this angle is 30 degrees, well, then the angle between our second value of theta and 180 is also going to have to be 30 degrees. So by taking 180 and subtracting 30, that gives us the 150, which is our other solution. Now, does that hold true when you're working with cosine? Again, I'm working with degrees just because it's a little bit easier to think of right away. But cosine is a little bit different. Here we're trying to see when does cosine of theta equal 1/2. And so here we'll put 1/2. And we see that there are two solutions between 0 and 360 degrees. And if I were to use my calculator, again, I'd have to be in degree mode. And if I take the inverse cosine of 1/2, we would get 60 degrees, which gives us that first solution that we're looking for. But what about the second one? Well, like sine, cosine has some symmetry as well, but it's on the entire domain here between 0 and 360 degrees. And so if we look here, if this angle right here is 60 degrees, well then this angle here would also have to be 60. So instead of taking 180 and subtracting 60, we'd have to take 360 and subtract 60. And that would give us 300 degrees. So on a domain of 0 to 360 degrees, there's two solutions of when cosine of theta equals 1/2. Same thing when sine of theta is equal to 1/2. Well, what if you were looking at putting this in radians? So here I have cosine, again, of 1/2. And now your calculator is not going to necessarily be very beneficial to you in this case because it's going to give you a decimal. But if we look at on radians, oops, I'm sorry. I'm trying to adjust to this new computer and it's not really working well for me. So here's my two values of theta. And again, if I use my unit circle, I know that one of them would be at pi over 3. What about the other one? Notice that it would be 5 pi over 3. And instead of taking 360 degrees minus the 60 degrees, I'd be taking 2 pi. So 2 pi minus pi over 3 would give us the 5 pi over 3. And so I want you to just be seeing that there is symmetry going on here and how we are finding these solutions. And that's going to take us to, I want to go right? Sorry, I'm just looking to see which one I want to go to. Yeah, we're going to start here. And now we're going to start solving these trigonometric equations, okay? Now, what you've got to think of is you need to think of sine and cosine just like a variable, okay? Just if we were to think about this here and let x equal cosine theta, for example, I would have 5x plus the square root of 2 equals 3x. And I know that each and every one of you knows how to solve that equation. And so now you just got to use that information to help you solve these problems here, okay? Now, first thing we would try and do here is put our x's together. And so I can subtract a 5 cosine theta from both sides. One thing that's getting me on this screen here is every time I touch it, it puts a marking. All right, so now I have the square root of 2 is equal to negative 2 cosine theta. All right, and now if you're trying to solve for x, or in our case here, cosine theta, I can divide everything by negative 2. And now we have cosine theta is equal to negative square roots of 2 over 2. Now, we're going to be looking on the interval of 0 to 2 pi. So if you use your unit circle, you can find those values. And we're looking at here that negative square roots of 3 over 2, or negative square roots of 2 over 2, we're going to look at 3 pi over 4, as well as 5 pi over 4. And if I were to just take and I just realized, sorry, I've got the sine curve up here. I should be looking at the cosine curve, my fault. Sorry about that. All right, there's your cosine curve. And so when is it equal to the square root of 2 over 2? You know, you've got 2 solutions for that. So there's your cosine. You're solving equations. Okay, and we just did that. So now let's take a look at this one. So you got the secants. So we're going to try and isolate those, put those together. So I'm going to subtract a secant theta from both sides. So this gives me 6 secant theta is equal to negative 4 square roots of 3. And then I can divide by 6. And we get secant theta is equal to negative 2 square roots of 3 over 3. All right, so, I mean, that's what we're, I suppose, yeah, so there's my secant. Now, you probably don't have your secants all on your unit circle, so you might choose to flip this around and be looking at now when is cosine of theta, which would be the reciprocal, so we'd have 3 over 2 square roots of 3. And then I can rationalize my denominator. So I get negative 3 square roots of 3 over 6, which is going to be negative square roots of 3 over 2. So that's what you're looking for the value of cosine, because you're looking at secant there. So then cosine being negative square roots of 3 over 2, so that would be 5 pi over 6. And also at 7 pi over 6. So you're solving for those values of secant. So now when you're solving equations, you're going to be doing the same thing that we were doing back in chapter, let's see, that would have been back in chapter 5. But now what you're just trying to do is look at it with, you know, your trig expressions on both sides, trying to combine them, just using some basic algebra skills. What you got to be aware of, though, too, is sometimes there's some quadratics that are built into this as well. So we've got 4 sine squared theta plus 8 equals 11. Now, if you guys are solving this like an equation, we would go ahead and subtract 8 from both sides. So 4 sine squared theta is equal to 3, and then I would need to divide by 4. So sine squared theta equals 3/4. Now, before I start figuring out what my values for theta are, I would need to take the square root of both sides. And this is the part where people forget. Now, when you take something and we have x squared equals 25, and you take the square root of both sides, you need to remember that x can equal both plus or minus 5. And so in this case here, we're going to be having that sine of theta can be plus or minus square root of 3 over 2. Take the square root of the numerator and the square root of the denominator. So we are not just going to have 2 solutions in this case, we are actually going to have 4 solutions. We're going to have 2 solutions of where sine of theta equals positive square roots of 3 over 2, and we're going to have 2 solutions for when sine of theta equals negative square roots of 3 over 2. And so now for my values of when it is positive square roots of 3 over 2, we are looking at pi over 3 and 2 pi over 3. And when is it negative, we're looking at 4 pi over 3 and at 5 pi over 3. And so right here we are taking a look at finding all of the solutions for when we're between 0 and 2 pi. And because you're squaring that value, it's going to make it that positive. All right, let's take this one here. I'm going to pause it 1 second. I have a note in my notes here. All right, my notes just wanted me to change this out here and put tangent instead, just for a reason in the end that we can look at. So, all right. So sometimes what you're going to need to do is you're going to want to solve trig equations using some factoring techniques, okay? And when we do factoring techniques, we always want to have things equal to 0, right? So we're going to have 0 equals tangent theta sine squared theta minus tangent theta. And at this point, what I would be able to do is factor out a tangent and then you'd be left behind with sine squared theta minus 1. Now, what I want you to understand here that, oh, actually, I'm going to wait. I'll do that in a second. Okay, so now that we've got it factored out, and I've got all these extra things here, what we can do now with those factors is we can set up our equation. Tangent theta can equal 0, or sine squared theta minus 1 can equal 0. It's just like you're solving a quadratic. So when I look at for when is tangent of theta equal to 0, so tangent's going to be equal to 0 from, and this one I don't really have to do any solving for, but theta, if you're going from 0 to 2 pi, so at 0 pi, and at 1 pi, and at 2 pi, at all of those values, tangent of theta is equal to 0. If I solve on the other side here, I'm looking for when does sine, I'm going to add 1, so sine squared theta equals 1. So then I take the square root, and sine theta equals plus or minus the square root of 1, so plus or minus 1. So now you've got to realize that there's going to be multiple solutions to this. So when does sine of theta equal plus or minus 1? Well, that's going to be at pi over 2 as well as 3 pi over 2. And those are our solutions. So we have a total of 5 of these solutions. Now, what I want to show you also, another option for you to do is you can use some of your trig identities, and we could rewrite, since sine squared theta minus 1, if we take because since sine squared theta plus cosine squared theta equals 1, sine squared theta minus 1, we could rewrite that as cosine squared theta, and that could be equal to 0. And so then if I wanted to solve this, I would get, cosine theta equals plus or minus, I suppose, 0 in this case. And when that's going to happen is at pi over 2 and 3 pi over 2. So it's just another option for you to do. You can rewrite some of your factors using your identities as well. All right, let's take another look at one using factoring. And I'm going to put everything on one side here. And what I can do here is I'm going to subtract square root of 2 sine theta and so now this leaves us with sine theta secant theta. And then I have to just be careful on this part here, because when I take 2 square roots of 2 minus the square root of 2, then that's going to give us plus 2 sine theta equals, this is going to equal 0. All right, and now what I can do is I could factor out a sine theta, leaving behind the secant of theta plus 2 equals 0. And now that you've got your factors, we can set them each equal to 0. And so sine of theta equals 0, well, that's going to be when theta is equal to 0, 2 pi, and pi, sorry, I missed pi in there. And then over on the other side here, I'm looking for, well, when does secant of theta equal negative 2? And that's, remember, that's the same thing with cosine then. That's the same thing as looking at cosine of theta. When does that equal negative 1/2? That might be easier to look at. And so theta would be at 2 pi over 3 and 4 pi over 3. All right, let's take a look at one final example, and hopefully you're seeing how you can solve these out. This one right here, it's already set equals 0, so I don't have to worry about that, but I can go ahead and factor this. Again, if you want to, just think of this as 2x squared plus 3x minus 2, and how would you factor that out? And so I can factor this out into a 2 sine theta, and then I'd put a sine theta here, and I need to get a positive 3 there in the middle, so I'm going to have to do a plus 2 and a minus 1 here. And so now I'm going to set each of my factors equal to 0. And so sine of theta, that's going to equal 1/2, and sine of theta could equal negative 2. Here, when does sine of theta going to be 1/2? Well, that's going to be when theta is equal to pi over 6, as well as 5 pi over 6. And then I get to sine of theta equals negative 2. Well, negative 2 is outside of our range for sine. And so sine of theta will never equal negative 2. So you won't have any solutions for theta on the other side. So our only solutions here would be pi over 6 and 5 pi over 6. So if you have questions, as always, please send them my way. We're going to spend another day on solving equations. And so hopefully this is just kind of an introduction. And I got to turn this off. Come on.